2, 1. We're having the most best Monday in the whole wide world, everyone. It's being recorded. Welcome to Studio Review. It's time for studio number, well, technically 11. What is this? Studio 4? Why are we 4? Wow, why do I look like my hair is just crazier? I don't know, whatever. I think it's like, what, Studio 4? Is it Studio 4 now or 5? 4 or 5? Already lost track. So, well, today's lecture 6, but I think we skipped one studio. So I think it's like 5. I don't know. The numbers are all weird. Numbers are all made up. They don't matter as long as we're still having fun. All right. Let's do this thing right here. I'm going to go ahead and start sharing my screen. Before we get started, anything in particular that anybody wants me to focus on while we're going through this? Anything, any parts and piece? No? Everyone's going to stay silent with me today? Fine. I will talk to myself. I'll laugh at my own jokes. Whatever. Do it all the time anyway. Kind of love working from home. All right. Let's do this. 11.11, make a wish. Studio, more functions. 11.11, make another wish. Point 1, sort numbers for real. Recall that using the sort method on an array of numbers produced an unexpected result. Oh, let's go see what that unexpected result is. Because Kyle didn't read the material. Uh-oh. Going over here to the sort examples, what does it do? Yes! Oh, fun stuff. Why does it do that? Who knows? I guess we'll find out. Anybody for brownie points know why it actually does this?
This Unicode.
Oh, very good, Rena. Absolutely right. It goes by ASCII code. It's not actually looking at the letter itself, but every character has a representation of a number called the ASCII number. Absolutely right. So that's what it's sorting on. Believe like A starts at, oh, it's like the 40s or 50s or something like that. There's a bunch of characters in there. Definitely, you haven't looked it up already, or they didn't put in the reading, go look up the ASCII chart. It is cool. There are characters that you never understood why they're there, but they're there. There's very weird stuff in there. Let's keep going though. Produce an unexpected result. Yes, because capital B or capital X was before lowercase b. What is this? Let's figure it out. Since JavaScript converts the numbers and strings by default, let's fix this. Okie dokie. Here is one approach to sorting the array. Find the minimum value in an array, add that value to a new array, remove the entry from the old array, repeat steps 1 through 3 until the numbers are all in order. Okay, well, that seems fun. Let's keep going on. 11.11.1.1 part A, very specific. Find the minimum value. Create a function with an array of numbers as its parameter. The function should iterate through the array and return the minimum value from the array. Hint, use what you know about if statements to identify and store the smallest value within the array. Use this sample data for testing. Okay, well, before we get any of this stuff, let's go and open up part A on Replit. Replet's going to open up as always. We go to the top right, we click fork Replit. Why do I keep repeating to fork the Replit? Because this is going to become very, very important as we get into other stuff that has to do with forking. So I will always say that. But the fun thing is that now it's going to load here and we're going to see what we have to do. Here is our comment, create a function with an array of numbers as its parameter. Function should do some things. Okay, pause. First sentence says, create a function with an array of numbers as its parameter. I was just given the starting sentence to start at least coding something. I have a starting point. So what I'm going to do now is just start. I said start way too much. We're going to go ahead and create this function here. So we're going to say function, and I have no idea. I think it's going to say sort numbers. So let's just call it sort numbers right now. So we just do sort numbers just for right now. So we're going to do that, and it says taking a number array. So I'm going to say num array right now. So num ARR. ARR is always an abbreviation to array. So our numbers, we take in that array. Cool. First sentence down. Let's keep going. The function should iterate through the array and return the minimum value from the array. Okay. Pause again. We're going to take this. I saw a funny meme that said pause a lot, so I'm going to be doing pause tonight. I'm sorry. That's just how it happens. I'm a millennial. Anywho, it looks like we need to return the minimum value. So what I'm going to do is I'm going to change this function name to find min value. That sounds a little bit better. So what this function is going to do is now kind of more given some context in the name there. So it's going to clearly find the minimum value and return it, hopefully. So the function should iterate through the array and return the minimum value of the array, which you know about if statements. Okay, so let's go ahead and write this. I need to iterate over an array. Ask yourself, what do we do if we need to iterate over an array? What do we use? Okay, we're going to be using a for loop. Very good. Absolutely. Heard it. A for loop. So I'm going to say let I equal 0. I is less than num array. And I forgot to put something on there. I'm going to go and finish my for loop. I plus plus. I apologize. And then those curly brackets. I need to turn on transcripts here. 1 second. There we go. Awesome. So we need to iterate over the loop. So we built the thing to iterate over it. But now in my head, I'm like, okay, I have to iterate over this array, but I need to find the minimum value. The minimum value is somewhere in that array, but how do I know once I'm on like index 3 or something of the array, what index 2 was? I need to remember what my last minimum value I saw was. That's what I'm going to do here. I need something to help me remember what my minimum value is going to be. So I need to create a variable. And that variable might change because the minimum value might change. Hence, I do need to use the keyword let for this. Let's call it min value. Now, this one's going to be a little interesting. What I'm going to do here is that we're going to just put 0 here just for a moment. We're going to use this to hold the minimum value just for right now. Now, we're going to just keep on going here, and we're going to come back to that in just a second. We need to still check to see if the index I'm at in the array, if we're looking at this one, 5, 10, 2, and 4, is the minimum value I've seen, or is the lowest value I've seen while going through the array. So I need to ask myself, is this the lowest value I've seen so far? If I'm asking a question, I typically need to use an if statement. So that's what I'm going to use here, an if statement. If min value is greater than num array at I, meaning if my minimum value is greater than the number I am looking at right now, because I'm iterating over the entire array, then my minimum value should definitely be whatever I'm looking at in that array right now. So I need to make sure that my minimum value is set to that one thing I'm looking at. So if minimum value is greater, as in it's more, than what I'm looking at in the array, that minimum value is no longer the minimum value. It's whatever I see in that array. So I need to set it into that min value variable. That's what I'm doing here. So that's cool. But now I'm down to the conundrum that I saw when I created this variable min value equal to 0. Min value equals 0. That's nice. But let's go through what this function would actually be thinking. For let I equals 0, I, whatever, less than num array, I plus plus. So my I is 0 at this point. Min value, ask yourself, is what value at our first iteration? Well, we set it to 0 here. It's still 0 down here. So this is 0. I equals 0. Num array, we're going to be using this one as an example here, is 5. Is 0 greater than 5? The answer is no.
No.
So therefore, this if statement will not be executed. So the problem here is that 0, though 0 is less than 5, 0 doesn't exist in this array. So if I return 0 right now, that's a bad answer because 0 doesn't exist in that array. So we should not be using 0. The same with this. If I put 990 or 9,999, or I kept going like this, I've seen this sometimes also used. This is also very unsafe because all you need is one array to be at 1 trillion to return the wrong result. So what we do here is we don't actually put a number in here to start up to hold our min value. Instead, we want to just give it nothing. And we want to tell everyone it's nothing. We haven't seen anything yet. So I'm actually going to call it undefined. I have no idea what my min value is just yet. So I set this as undefined, basically nothing.
Kyle, is it safe just to put the first item in the array in there?
Technically, you could.
Is it safe?
It is possibly safe unless there's no 0th index in the array. If you pass it an empty array, technically that 0th index doesn't exist. Hence, you're going to get an index out of bounds error. So instead, it's more safe just to set it as undefined. And when we come down to this if statement now, we say, okay, if the min value is greater than num array, but the first thing I should be checking is like, okay, if min value equals undefined, or the min value is greater than the number array that I'm looking at right now, then set that min value to num array at that index I'm looking at. So if my min value is undefined, which it should only be on the first iteration, it will automatically set that min value to that num array at index I. So that is a small little thing that we need to do to protect ourselves in this kind of algorithm that we're talking about. I hate using just the word algorithm, even though it sounds cool. Next thing we need to do, the final thing we need to do is make sure we return the min value. All right, I'm going to pause here. Any questions about what we just did here for number 1?
I have a question.
Yeah.
So I think before, whenever we've done like loops for undefined numbers, we used whiles. Is there a reason we use a for now?
Depends on what the situation was that you were using the while with the undefined number. Because this number will only be, or this value will only be undefined for not even a full iteration. So if we look at this at index I of equaling the 0, our first iteration, it comes down here and sees this if statement. The first thing it is min value equal to undefined? Well, we just set it as, and it's the first iteration. So it is true. And we have an or here. So if one of these things is true, it's going to execute this. If one of those things are true, it's going to execute this. So this min value is now going to not be undefined, but it's going to be instead, looking at this example here, 5. So in this case, we wouldn't want to use a while loop, because if we said while min value is undefined, then we'd only do one iteration. I want to go over the entire array. So to answer your question, it's all about that situation. In this case, we want to iterate over the entire array no matter what. But that while loop sounds like there might have been condition involved while something was undefined, then loop. Hopefully that helped. Does that help out a little bit? Okay.
Yeah, thanks.
Absolutely. All right. So there we go. We are returning that min value. Let's go ahead and oh, I'm sorry. Any other questions out there before I go ahead and test this thing? Because I could be just blowing smoke right now. We have no idea if this works.
I do have a quick question. So as far as like just like a good coding practice, on ours we put let min equal, like, so after function we did list min in parentheses num, and then let min equal num in square brackets 0, like as like the starting
Right.
thing.
So
then we looped through.
So the only dangerous thing about that is that what if you passed in an empty array?
Oh, okay.
Is there a 0th index in an empty array?
Gotcha.
And that's, yeah, exactly. And so that's why most of the time, yeah, that'd be fine. But if you really want to be safe, this is the tactic you'd want to take, just because there might not be a 0th index in your array.
Okay, gotcha.
Yeah, great question. Honestly, these are those small little things that you just learn over time, because I broke this a million times before I'm able to teach how not to break it. So no, it's all okay to go ahead and try out those other tactics.
In for loop, I less than num array dot length or num array. Is this fine?
Can you say that one more time? What did you do with your I?
Yeah, in for loop, I less than num array or num array dot length.
Oh yeah, absolutely. Sorry about that. Thank you very much. Yeah, it should be dot length.
Okay.
Yeah, I forgot that property there.
Okay.
Very good call out. Make sure everyone's paying attention. Fantastic. All right. Any other questions on this? If not, I'm going to go ahead and just test one out down here real quick. Find min value and then nums1. So we're going to just go ahead and try out this one right here.
Kyle, it should be nums.
Yep, I saw. Thank you very much. Got it. Awesome. Nums, not nims. I'm going to run that, and it says 2. Fantastic, and that's exactly right. Let's go and try nums2 now. See what that one is. 44 looks good. And then final thing is some with decimals. Okay, nums3. Very good, 3.3. Awesome. Looks like this is all good. All right, anything else on this before we keep on going? All right, let's keep on going. On to 11.11.1.2 part B. Ooh, create a new sorted array. Create another function with an array of numbers as its parameters. Within that function, do a bunch of this stuff. That's a lot of stuff. Let's go ahead and open up the replit first before we go through what we need to do. Top right, fork replit. And perfect. We have the find. Oh, look at that. That's nice of them. Brought over the Feynman value and everything for us. Look at that. Oh, look what they did. That's fine. I'll take it. I'll take it. I see what they did there. Technically that works because there's no empty arrays here. You know what? Let's just see. Let's just see if it actually works. Could that just be my own thing? Like 0th index could be forgiven in JavaScript. I don't know. Micah.
Well, my only question is both times when I run it with undefined in min and array 0, it outputs undefined both times. So I was just kind of curious, and we don't have to spend that much time about it, but like the actual output to the console is still undefined when it's an empty array.
Make sure you're including that in your conditional for your if statement.
Okay, gotcha. Sorry about that.
Nope, all good. Just make sure that's there. And everything should be considered. It looks like it's okay to put that 0 in there. Of course, JavaScript, you're always trying to help. So if you have that bracket 0 in there, I mean, feel free to keep it in there. My personal thing is that will work with JavaScript. With other structured languages, it might be a little bit more upsetting, but bracket 0 looks like it does work. So I take that back. There are 2 fun ways to paint this picture. So feel free to use that if you want to. Oh, it's coding. There's a million ways to do one thing all the time. But either way you want to do it, whatever makes you happy. I'm going to be continuing to use undefined just for a little bit, just so we get more used to undefined also, because it is very prominent in JavaScript. So, all right, let's keep going here. So create that function with an array of numbers as its parameter. The function will return a new array with the numbers sorted from least to greatest value. All right, I'm going to go ahead and do that. So to create that function, give us more space here too. As always, I say function and then sort least to greatest, and then num array again. There we go. All right, least to greatest value. Cool. Within the function, define a new empty array to hold the final sorted values. All right, let's see. I'm going to say const sorted array, because it says it's going to be the sorted array. In the directions, like, okay, let's call it sorted array then. That's what it's supposed to be. It takes years of practice to name these variables, I swear. But I promise, it just comes more natural after a while. I'm not just pulling these out. I've seen this before. That's the only reason why I'm like, let's call this. But if you're calling it like cat1 and cat2, that's fine too, just to let you know. All right, part B here. Use the find min value function to find the minimum value in the old array. All right. New array, so numbers. Use the find min value to find minimum. Okay. Okay. Const min value equals find min value, and we pass in the num array. Remember, we're passing to that parameter there. So the parameter is going to be passed in here. We can reuse this right here. It's information that's just flowing through the function. So we're going to pass that num array in there, and it's going to find that min value for us. I just marked it as constant right now because I don't see it changing. If it ever changes, I'll put it as let. It's just me. So find min value function to find the minimum value. That's what we're doing on part B there. Awesome. Add the minimum array value to the new array and remove the minimum value from the old array. It's a lot of stuff right there, but I guess we can do that. Sorted array dot, what do we do to add to an array again?
Push.
Push it in. Yeah, actually, absolutely right. Sort. What do we call it? So we do that min value. All right, and then it says to remove it from the old array. I'll even help us out here. I'm going to type it in there. How do we remove something from an array here? How are we going to do that?
Splice. Or shift.
All right.
Splice.
All right, we can do splice. We'll do some splicing. All right, we got some splice here. What are we to put in splice?
The index of the one we want to remove.
I like that. Can you talk me through it? Anybody got an idea how we can get the index of this? There was so much confidence there. And then it was like, no, you do it. Come on. How
Would
do
it
we
be
get this?
in-
How do we get an index of? We can't. Well, we could loop it.
Say
but
index of.
Would you do your array dot index of?
very good. The array of index of. So the
Index
array we're using though is what array?
Find min value.
Num array.
Num array. Num array.
Remember, num array is array. Find min value is the function. It's the one doing the work. It's the one doing the work. So the array is num array. And then what helper method were we going to use helper function?
Dot index of.
Very good. Index of. And we need to find the index of.
Find min value.
Ooh, this one's a
Min
tricky
value.
one.
Min value.
No, find min value.
Min value.
Min value.
Find min.
Yeah. Min value. Yeah. We might have an issue here. JK, everything's fine. Nothing's going to explode. And I'll even help you out here. I'll put the delete count. Only one there. Cool. There we go. So now we're splicing on that array. Cool. We're looking good so far. All right. Repeat parts B and C until the old array is empty. All right. Sounds like we got to repeat code. What tool do we use to repeat a bunch of code?
For
Wow.
loop. Loop.
We
Yeah,
could
why
do
not?
a while loop. Yeah, you know what? We could do a while loop in this. I like that idea. Let's do a while loop here. So what I want to do is make sure I identify the parts of the code I want to loop over. If I'm trying to add all of the numbers into this sorted array over and over and over, I need to first find the min value, then push that min value in there, and then remove it again. These are the 3 lines of code I want to repeat over. So that's where I'm going to write my loops. I'm going to say while.
Could you say that one more time when you finish? That was.
Yeah, absolutely. I going over that a little fast. Yeah, let me go ahead. So when I'm about to write a loop, it said I need to repeat part B and C. I need to identify the code I want to repeat over. So the question is, okay, what's going to build this sorted array? Well, they told us B and C, find the min value of the function. Use the find min value function to find the minimum value in the old array. That's part B. Add the minimum array to the new array and remove the minimum value from that past array. Those 3 steps are what we need to repeat over. This is the first step that they said in part B, and these are the 2 steps they said in part C. That's what gave me the hint that I need to repeat over these 3 lines of code. Hence, and I like the idea, we're going to do a while loop over those through. I'm going to just put open and close parentheses there just for a second. And then I'm going to bring that code in there. Now it comes the fun part of the while loop. What in tarnation are we going to put inside these parentheses? Can I get an idea?
Array length not equal to 0.
I like that. Num array dot length is not equal to 0. So I want you to keep looping over these 3 lines of code while my num array actually has numbers inside of it. That's what we're doing here. I like that idea. So hopefully this works. Otherwise, we're stuck in an infinite loop. Hence the dangers of while loops, but they're still, again, very powerful as long as we have all of our T's crossed and our I's dotted. All right, so we have our while loop there. And then finally it says return the new sorted array. So say return, and then my sorted array is up here on line 14, sorted array. So it's sorted, ARR. Cool. All right, it looks like this is written, and it takes in stuff and returns stuff, so now we can kind of test it. So let's go ahead and do that. So I'm gonna come down here, and I'm gonna console log, because I want to see it over in the console, that's why I use console log. So sort least to greatest. Anybody got nums 1 through 3? Someone choose one for a test.
Nums 1.
All right, nums 1. Perfect. There we go. Let's go and run this and see what happens. Look at that. Looks fantastic. We got a 2, a 5, a 10, and a 42. It looks like everything is being organized properly. Awesome. Let's go and try a couple more here.
3. Okay.
So we got negative 44, negative 10, negative 2, 0, 0, 3, 3, and 5. Neat. All right, let's keep going. One more, 3 here. Run that. We see a -3.3, a 0, a 4, a 4.4, a 5, a 5, an 8, a 10, and 200. Looks like everything is being sorted here for number 2. So let's go back up there and take a quick look at that function. So any questions on this one?
Kyle, is it okay if in our studio we put it like in line 15, we said less than 1?
Technically you could, as long as it's equivalent to not 0. So while num's length is greater than 0, so we can do greater than 0.
No, less than 1. Less than 2.
So you said less than 2. Is that what you're saying?
Yes, yes.
So that's saying if my num_array.length is less than 2, then I want you to loop through this.
Yes.
So if we run through, it won't run anything. Because how long, what's the length of this array?
4.
4. Is 4 less than 2?
No.
False. Very good. So therefore, will this while loop run?
No, it won't.
It won't. So we have to make sure while our num length is greater than 0, that's one way we could do it, or not equal to 0. So while loops are a fun way to think about it, almost in the opposite way. I want you to loop while this thing is true. While our num array still has stuff in it, its length is greater than 0, I want you to continue to run. That's what that conditional is saying.
Could we use greater than or equal to 1?
If we do greater than or equal to 1, in that case, we're going to stop a little bit prematurely, I believe. But let's go and take a look. If we go ahead and come down here and we do nums 1 instead, let's see what happens. Let me see. Technically, yeah, it would be because you're equal to 1. So 1 would run the last time, then it becomes 0, and then you're fine. Yeah, okay. That's good.
That's how I did it, and I was like, I know it works, but I don't know if there's any pitfalls that I might encounter that didn't show up in this. So
No, all good. I forgot. Yeah, it's equal to 1. So on 1, it will loop back one more time, become 0, and then stop executing. So yeah. Very good. Yeah, if you did, what I was thinking is if you did greater than 1, then we're going to be missing just one more piece. But no, you got me. You got me, Amy.
Thanks, Kyle.
Absolutely, Hannah. Any other questions?
Can we use for loop instead of while loop? Can we use?
I would not recommend it. And I would not recommend it because of a past question we had, is that we do not want to change the size of the array while we are looping over it. In our instructions, it says that we need to remove the value from the old array. That means we're manipulating the size of the array. If that happens, we should not use a for loop.
Okay. Okay, thank you.
Absolutely, great question. All right, anything else? Otherwise, we are moving on. All right, let's keep going. That was a fun one. All right, 11.11.2. Isn't sorting just so much fun? More on sorting numbers. The sorting approach used above is an example of a selection sort. The function repeatedly checks an array for the minimum value, then places that value into a new container. Selection sorting is not the most efficient way to accomplish the task, since it requires the function to pass through the array once for each item within the array. This takes way too much time for large arrays. It is absolutely true there. Fortunately, JavaScript has an elegant way to properly sort numbers. Here's a nice visual comparison of different sorting methods. No, thank you. Not to, fine. All right. My pure curiosity just got me. Oh, I already know where we're going. Nope, we're backing out of this one. That already looks like a headache. Though, honestly, do look up sorting algorithms. They are amazing. Very intelligent people have come up with crazy ways how to sort things just in language. It is Oh, they are beautiful. Like, I'm nerding out right now just thinking about that. They are absolutely, everything on your computer is sorted. How Google searches your stuff across the web in under a second is by sorting algorithms. It is fascinating, absolutely fascinating. Anyway, I'm going to stop cheesing about sorting algorithms and continue on. Feel free to use Google's bubble sort JavaScript, also bubble sort is one of my favorites, to explore a different way to order numbers in an array. Also, they make for fantastic interview questions, hint, hint, are sorting algorithms for, not typically for like beginner entry level positions, but usually intermediate to senior. They will give you some hard hitting sorting algorithm questions. All right, 11.11.3 part C, number sorting the easy way. If you search Google JavaScript, if you Google JavaScript sort array of numbers or something similar, many options appear, and they all give pretty much the same result. The sites just differ on how much detail they provide when explaining the solution. One reference is here for W3 Schools. W3 Schools is an amazing resource, and it will continuously be a great resource way into Unit 1 and Unit 2. So if you have not checked it out, check it out. It's the coolest site. Yeah, there's our sort. We know about sort. We've seen that today, actually. So let's keep on going. End result, the JavaScript syntax for numerical sorting is array name.sort function a b return a minus b. Absolutely right. Here, the anonymous function determines which element is larger and swaps the positions if necessary. This is all the sort needs to order in the entire array. Use the syntax listed above. Sort each sample array in the crazy order. Sort each sample array in this descending order. Geez, I cannot read right now. Does the function alter array name? Did your sorting function from part B alter array name? All right, it's a lot of stuff. Let's go and open this up. Work the replit there. Take a drink of water. Almost there. There we go. All right, we got our 3 nums there. Sort each array in ascending order. Okay, so let's go ahead and start that. First, I just want to see what sort does if we just sort it without putting anything into it. Let's say nums1 dot sort. We've seen sort before. So I'm just going to run that. See what happens. Doesn't do anything. What the heck? All right, well, that's fine. We're going to go ahead and make it do something. How do we make sort do something more customized? What do we need to insert into it?
A function, anonymous function.
Very good, Blake. I like that answer. Anonymous function. So remember, when we insert an anonymous function into these helper methods or helper functions, they all have their own personality. With the map one you saw, we added an item in there. We added an item in there because item is what it needed. For a sorting algorithm, we don't have items. We actually have left and right. So for this one, I'm going to say function, and then we need a left and right. A and B is typically the terminology for those sort functions. Now, as it told us, we need to return A minus B, I believe. That's what we got from the studio itself. Excuse me. Let's go and run this and see what happens now. Now we're actually sorting in from least to greatest. And what I'm going to do is actually I'm going to take out this so we don't confuse it with the console log there. I'm going to say const results, just so we actually have some separation there. Run that again. See, everything works the same. So awesome. We are doing it in ascending order now. Cool. Let's go and see if this works for nums2. We run nums2 here. And looks like we are also getting that in ascending order as well. Last but not least, of course, doing in nums3. Very cool. Awesome, awesome. All right, so this was ascending order. Any questions on this one? Because we did insert an anonymous function here. We did kind of look at the studio a little bit, but any questions on this in particular? Or we do descending?
My question is,
yeah.
How do we get it to where because right now I think in my mind that it's hard coded to just sort in one array. We're not actually sorting any array that's declared. So would we need to have something like in the previous exercises where, you know, it's not hard coded to just whichever way we put right in here? You know what I mean? I'm wondering if I don't really actually formulate my questions too well.
No, all good, all good. So are you asking,
like, do we need to make another function for like sorted arrays and then have a console log sorted arrays like we did before?
so that's kind of what we're doing here. Are you referring to putting it into a variable and then printing out that variable?
I'm referring to like what we did in exercise 2, because in my mind the first thing I was thinking was if we copy all the code from what we just did in exercise 2 and put it in the new one, in my mind I'm thinking maybe sorted console log sorted nums1 dot reverse. I haven't tried it just yet, but it's just what
So
I
are you talking about this one for part B in the studio review? So this one, I mean, we can always put it all in a console log if you wanted to, but like I just said, I want to separate it because in this one we don't have to insert not a giant, but we don't have to insert an anonymous function. It got pretty ugly if I had a console log wrap in the entire anonymous function. That's kind of why I separated it out.
Okay.
Remember, this is just to save us a line of code here, just to save us a line of code. To separate it out, it was just for readability. Sometimes that's the best thing to do for us people, us humans, to actually be able to read it. It's nice to just split it out, kind of like what we did here. We put it into a variable and then printed it out.
Okay.
Yeah, so just readability there. Absolutely. All right, but in the end, it looks like all 3 of our arrays are being sorted properly. So we're good there. Any final questions about ascending order before we go to the next part? Need like an auction guy behind me, like going once, going twice, sold to part B. Let's go. Here we go. Down here, descending order, result 2. Result 2, and then we're going to console log that. I'm going to comment this out so we don't get 2 different results there. All right, so we need to go in a descending order. Does anyone have an idea how to do descending order?
Reverse B and A.
I like that, Ellen. Absolutely right. We're going to reverse B and A. So instead of A minus B, it's going to be B minus A. Let's see what happens when we do that. Look at that. We get it absolutely in reverse order there. We have 42, 10, 5, and 2. So what we did is to reverse our left and right hand side. Let's go and see if my JavaScript sort here will help me out. Yeah, that's right. I'm always there. I'm always trying to like look on which one's the left and which one's the right. Yeah, so I mean, usually I get the question, if someone's really curious about the sort, is like, why do we do A minus B? And so like I was kind of explaining in the lecture, A minus B, it's either going to come with 3 different results. It's either going to be a positive number, a negative number, or a 0. So it can be a negative 200, depending on what A and B are. It could be a positive 50, or it could be a 0. But regardless, you come around with 3 different classifications, 3 different possibilities: positive, negative, and a 0. Positive means to swap the 2 numbers, A and B, one way. Negative means swap them the other way. And 0 means to stay right there. That's why we do this equation in there. If you're really, really caring. So hence why we reverse the numbers is that in that case, we want them to reverse, or we want them to swap the complete opposite way, which therefore threw them in reverse position. Hence, that's how we got descending order instead. So any questions on that? Any questions at all? Nothing? And we're getting positive vibes or negative vibes about these sort algorithms?
Positive.
Positive? Okay. Good. Good. No one's wanting to talk tonight. Come on, everybody. Wake up. We gotta get through this whole thing.
I do have a question
Thank you,
real
Blake.
quick.
What's going on?
All right, so if we just did nums3 sort without the function, it would go 10 to 42 and then 5, correct? If we did
What was the first? Sorry, if
nums3
you did what without the function? I was trying to get that last part.
if we did nums3 dot sort without the function, it would then give us 10 to 42 and 5, correct?
Technically, this one, it will not sort it at all.
At
if
all?
we just do dot sort, yes.
Oh, because that's right, it doesn't sort numbers. So I'm just wondering how it got to put in that specific order. I'm not seeing what is going on in that function that made it do 2, 5, 10, and 42 like we won. Yeah, see? Oh, okay, I had that wrong. Yeah, well, no, that's what I had in my mind. I'm sorry. Nums1 would have been 10 to 42 and 5, right?
For sorry, for which?
Nums1. If we change line 7 to const result equals nums1 sort.
Yep.
All right, and it does sort that to 10 to 42 and 5. So why, when we put function A, B, does it then correct it to 2, 5, 10, and 42?
Okay, so for this one, right, what we're seeing is technically sorted according to the ASCII table. If we look at each individual characters to the ASCII table, it goes 1, 2, 4, 5. Look at the beginning numbers.
Right.
So I forgot if it goes by the first or second number. Let's actually take a look at that. Let's see, sort 2. Yeah. So it is technically sorted.
So now my question is, when we put that function AB, what is going on right there that makes it take the 2, 5, 10, and 42? So like once we did line 7, you know what I mean?
Yeah, okay. So when we do this dot sort, what it's doing is just taking the first number. So we see a -1, a -2, a -4, 0, etc. So it's only taking one of the characters and going by the ASCII scale there. It's not actually using the full number. So the thing to take away is dot sort is not taking the full number into account.
Okay.
When we create the anonymous function, and we place it inside of that sort, we are now taking the full number into account. We're taking the full 10, not just the 1 or the 0.
And that's all the function AB does. It just takes the whole number instead of just the first portion.
Well, it forces the sort not to use its traditional default, which is to use the ASCII table, but instead use what the actual value is, the number.
Gotcha.
So dot sort is better for names and like strings, but it's not really built for numbers until we include an anonymous function like this to say, hey, actually use the value that's actually in the array to do your sort. So yeah.
Okay. All right, thank you. That's what I was trying to see what that definition of it basically was. It's now taking the whole value, just not the first one. The first one.
Yeah.
Okay. Thank you.
Absolutely. All right, any other questions? All right, we're gonna keep going then. There was a few other ones that we want to go over here. So we did the sort from increasing order and decreasing order. Does the function alter array name? I don't know where array name is coming from. Okay, yeah, there we go. Let's go back and see that real quick. Is it affecting nums2? So what we're going to do is we're going to go ahead and print nums2 next to result. So the question is, does this dot sort directly impact nums2? Let's go ahead and find out.
It is.
Looks like it is.
Yes.
What am I doing? We're going to go nums1. What am I doing? Oh, I was like, what am I doing there? There we go. So it looks like it is directly impacting that. Yep. All right. Next question is, did your sorting function from part B alter array name? Technically, We go over here to part B. Is this B? Is this A? That's A. We need B. All right, yeah. Yeah, this is part B. Well, let's go ahead and see what it does. No, that's part A. There's part B. Okay. We're going to start from least to greatest. So we're going to say nums1. So we're going to print out nums1 right next to it as well. Go. Does it affect nums1? Or does it affect the array?
Yes. It took
It
out all
does.
from there.
Yes.
And it affects it pretty dramatically. It removes all of the elements out of the array. At least the other one had all the stuff still in there. It wasn't in its original order, but at least it was in there. This one just completely wipes it out. So yes, both of them will actually impact it. This is the case because it is updating that container. Remember, the array has a container that's built around it. You can do whatever you want inside of the container of the box. The box stays the same. We're manipulating what's inside that box. Therefore, that's what we're peeking into here. In another word, that's called a reference. We're updating the reference of the array. We'll learn more about references as we move forward into the units, but just want you all to know that. Cool. Any questions about that?
When you say reference, you mean like the array pointing to the container, right? The array name pointing to the container.
Yes, technically it has to do with the pointer. Yep, absolutely. So it's that array is pointing at that particular container. That container it's pointing to is technically the reference. Yep, or it is the thing that it's referred to. Yeah. We'll get more into references and kind of what they actually mean and everything. But yeah, you're absolutely right, Hannah.
Thanks. Thank you, guys.
Absolutely. Any other questions? All right. One more time, and then bonus mission, but one more time, 11.11.4 here. So why write a sorting function? Each programming language, Python, Java, C#, JavaScript, etc., has built-in sorting methods. So why did we ask you to build one? It's kind of like a programming rite of passage. It really is. Design an efficient sorting algorithm. Excuse me. Also, sorting can help you land a job. Told you, pinky promise, it's like a big interview question. As part of a tech interview, you'll probably ask to do some live coding. One standard go-to question is to sort an array without relying on the built-in methods. Knowing how to think through a sorting task, generate the code, and then clearly explain your approach will significantly boost your appeal to an employer. Absolutely right. Luckily, I am not a mean interviewer and I never give the sorting issues, but if you can tell me how something sorts, I will definitely, that's like a good flag in my book. So absolutely right. Sorting algorithms are huge in the interviewing process. That and loops and honestly critical thinking here and there, but so is that part of every single interview. But any questions on that section? All right, that is the fun stuff right there though. That's what we're here. We're learning here to learn a code, apply that code, and then in liftoff is when we get into all of that fun interviewing stuff. So cool. All right, everyone, that was 11.11.4. That was the end of the studio. That's all we got. It is 11 to 8:57. As always, feel free to log off, but we're going to hop into the 11.11.5 here, the bonus mission, refactor your sorting function from part B, can't really see the rest of it, to use recursion. Are we all ready to tackle this one?
Yes, please.
All right, let's go ahead and do this. It's part B right here. All right, so it says that we need to do this one to do recursion. So let's go ahead and do that. So let's see what happens when we do this. So what we need to do is that we need to remove this while loop, and we want to, instead of looping over it, we want to essentially sort our array. How can I best? I remember this one too. It's like, how do I explain this exactly without just like being like, it's just this, it's that. You just do that. So what we want to do is that with recursion, it's almost like a way to loop, kind of, by using yourself. Kind of like you're just like Inception there. The dream within a dream within a dream. But finally got to wake up from that dream and come on back to reality. With recursion, we want to sort and we want to sort and we want to sort. And once we're done, finish with stuff to sort, aka that array is empty, we want to come back to reality. We want to bring back that sorted array. So that's what we're going to be doing by doing this with recursion. So let's go and do this. I'm honestly going to be taking a stab at that. Do I know the right answer out of the gate? Just like all of these practices, I really don't. Like I remember it here and there, but honestly, I haven't done this thing in like 4 to 5 months. So I really got to remember what my approach is going to be here. All I know is that this while loop's gotta go. So that's what we're going to do here. We're going to take this code out. Well, actually, you know what? Just for our record keeping sake, I'm going to just go ahead and copy. Bring it down there. If you have code that works and you know you might use it or just really like how it looks or something like that, keep it around. There's nothing wrong with just commenting down your code here so you can use it later. There we go. All right. So the 4 vital lines of code that I know I'm going to need is this. These are the things that are doing the sorting. I mean, of course, we have that loop that goes over and turns the crank, but it's turning the crank to do these 3 lines here. So that's what I know I'm going to need. Now, what I want to do is still the same stuff. I want to find the minimum value, have the min value, push it in there, remove the minimum value, and then I want to find the next minimum number. But who's already finding the most minimum number? It's right here. This min value up here is. So what I'm looking at is like, okay, I know this line up here finds that min value. That's what I want to do again. I basically want to do all 3 things like this again. So I'm like, okay, I could use a while loop, or in this case, because the instructions ask, I should use recursion. Or I can just use myself again to do exactly what I just did. It's like making a copy of myself, like, Kyle, do this thing again. Like, okay, I'll do this thing again with 1 less number in that array. So what I'm going to do here is say sort least to greatest and num array again. So cool. All right. I know now that it's doing that again. So what's going to be returned from my sort least to greatest? It's going to be the array again. It's going to be some array. Let's see how I can do this exactly. So what I do is I want my sorted array equal. Let's see if that actually works. Well, no. Stop it. All right, what we're gonna do is catch, say const returned sorted array from here. All right, so what it's gonna do is have the sorted array. We're gonna have another sorted array up here. I have no idea what this is gonna look like. So I kind of wanna run it just to see what I have to work with, because I don't exactly know the right answer. So I just wanna see all the pieces of the puzzle and see how we could possibly put them together. But the one thing I know about this, that's just coming from my intuition, or possibly that you're all saying this, like, you know it's going to happen. Right now, we know recursion is powerful, but dangerous. It can possibly cause an infinite loop. If I ran this right now, it would technically cause an infinite loop. And let's go ahead and just see that just for fun. And go and run this. We're going to see this error over here. If you see this error over here, says maximum call stack size exceeded. This is called a stack overflow. This is basically meaning that you have ran out of allocated memory for your environment. Basically, I don't have enough memory to continue this infinite loop. It stopped, it crashed. So I caused myself an infinite loop. So I need to make sure that doesn't happen. So what I want to do is I'm going to say if num array dot length equals to 0. I just want you to return. I'm going to think, just like an empty array. I want you to return nothing. Everything here is expecting an array back. So I'm just going to say, all right, I'm going to stick with the times and just return an empty array. Why did I do this? Don't even think about it as recursion. Think about it as just a normal situation. If you pass in an empty array here, num array, is there anything to sort?
No.
If you pass an empty array, is there anything to sort?
No.
Exactly. If there's nothing to sort, what is the answer to the sorted array? An empty array.
Empty array.
There's nothing in there. So this has nothing to do with recursion. This is just protecting you. Saying if they pass in nothing in there, give them back nothing. Because like bro, you sent me over nothing. I'm like, sorry, bro, that's all I got. And they'll give you an empty array back. That's what we are talking about here. Literally, again, nothing about recursion. So cool. We have this protector in here. Now back on to the top about recursion. This protects us now from an infinite loop in recursion. Because when we finally, every single time we call ourselves, we splice out a piece of that num array. Eventually, if we keep splicing stuff out, we're going to run out of stuff in our array. Hence, we're going to hit a length of 0. Once we hit a length of 0, we actually return from this function, hence ending that infinite loop. So let's go and run this one more time and see what happens. Awesome. That's not anything we want to look at just yet, but the best thing is we didn't get an error on the right-hand side. That's what we were looking for here. So I'm going to pause here just for a moment. Any questions on this before we start diving a little bit deeper? Because we're going to see exactly what this thing is thinking when it loops through. All right, let's go ahead and take a look real quick. I'm going to console log down here. I'm going to console log 2 things. I'm very curious to see what, one, my sorted array looks like, and my return sorted array looks like. Let's go and see what happens here. All right, interesting. So sorted array on the left-hand side, return sorted array on the right-hand side. 42 and nothing, 10 and 42, 5 and 10, 2 and 5, and then 2 and nothing. All right, interesting. Interesting. What can we do with this? Well, I know there's only one number in each of them, which is fine. So we got to figure a way how we can push everything together in order to make one final array there.
Concat?
Could possibly concat. I'm gonna always remember how to do that. So let's go ahead and look up concat for the arrays. If my internet wants to work today. Look at that. Let's go ahead and try concat. Let's see if that works. Don't exactly know what's going to happen here, but when there's not a problem to just try it. I need part B again. Nope, not that one. I need you. All right. Let's go and see this. So what we want to do is we want to create a new sorted array. So we're going to say sorted array equals, actually we need to do that below here because we're going to add these two. The two arrays we're going to add together are the returned arrays that comes back from the recursive call and whatever we had up here originally that we just pushed that thing into. So what we do is sorted array dot concat, and then we'll go ahead and concatenate the returned sorted array. There we go. Let's go and see what happens if we do this. Oh, touche. No one even caught that. Come on, everyone. Drink some coffee or something. It's assigned to a constant variable and no one called me out for it. Like that's the easiest way to just call out somebody. All right, look at that. So it looks like in the end, the returned sorted array will have all of the final numbers in there. So in the end, why would you have that in there? I think I went the wrong way here. I'm gonna change this all to let. Again, like I said, for the sorting and the recursive thing to come in, I always got to remember exactly which way goes which. Yeah. Okay, so let's go through this. So if it returns an empty array, then we come down here, we find the only value, array.splice, remove it, awesome. Okay, so the number array has that. Find the next, so least greatest, so it's going to return back that. Array every single time is going to be on the left-hand side, right? 10. Oh, why are we doing it 4 times? Oh, that's why we're doing it 5 times. Like, why are we doing it 5 times? Oh. So, okay, so what's going on in my head? I apologize. Is the left-hand side, like I said, this is a fun one. Left-hand side is our sorted array. This is what I actually want to return to the user. So we have our correct answer here, but it's one line up. We're sorting it 4 times, but it should, or sorry, we're sorting it 5 times. We see 5 lines here. Unless I am going absolutely bananas. Yeah, we're doing it 5 times. So on the 5th iteration, it goes back to empty brackets because we're returning that empty brackets, which is fine. What I need to do, okay, so it outlines, because it's going to be, it finds minimum values. So it's going to be 2, then 5, then 10, then 42, and then nothing. Nothing. Yeah, I should just add back up. Unless I have to do it down here. Turn sorted array. What happens there? I actually didn't know that. It's really just a hit or miss. Huh. What do I get for trying to do a brain buster here at 9:10? Did anybody got ideas out there? Let's hear from the crowd.
Scroll all the way to the bottom. Scroll all the way to the bottom. And our console log there is telling us.
Oh my gosh. Have I been doing this? Thank you so much. I've been console logging. That's one. I was like, this should work. What am I doing? I was giving myself a conundrum. We are so thank you so much. I was like, why am I? It's like, am I going crazy? I'm about to quit my job.
I know. I went through the same thing and I was like, why is it doing that? I found it.
What the heck? Thank you very much. Okay, so for everyone out there, what was happening is that I was printing out 2 things in our console. Like I had nums1. As we saw, nums1 is affected. It just removes everything. So that's why we're seeing an empty on the left-hand side. It's like, why isn't this working? So that's why we're getting two answers there. So if we run this again, get that. So if we just get rid of this console log as well, so we are just returning the ending piece there, we see that we get back the sorted array. So I apologize for the confusion. We had it right. We had it right. It was just that console log at the bottom was throwing me off there. Thank you again for pointing that out.
Thank you, Kyle. That was really nice.
Yeah, absolutely. I'm sure that was fun for everybody.
Yeah, because we in our group we had we did the parts ABC fast, but we were stuck here for a long while. So thank you for explaining it.
Yeah,
Can I see the console log again?
Yeah, for sure. We're going to go ahead and test it here. We'll go ahead and test it with nums3. Just make sure. Cool. We're still getting it with recursion. Awesome.
Can I ask a question not related to this when it is over, when everybody's done?
Yeah, absolutely. Just remind me at the very end. So sticking it with the recursion here, anything about this approach that we want to go over? We can do it loop by loop too, if that will help out. We'll go to nums1, so it's only 4 loops, pinky promise.
Okay.
So what made you want to put it as a constant versus a let? Because in my head, I did too.
Which variable?
Like at the beginning. Let me see. The sorted array.
Oh, as a let. I mean, we know we're going to be sorting the array, so I mean, why I put it as a const beforehand? For the original part B?
Yeah.
Because I expected us only having to push in the new value into the array and then returning it.
Because that's what I was thinking too. And then whenever you changed it, I was like, okay. And then it like took me like a few more seconds to be like, oh, okay.
Well, so why I took it away is because I knew with recursion we're going to have to take an array and merge it into another array. Hence, it's going to change. That's why I changed it back to let for this approach. But I'll be happy if that's the biggest question we have is why it was something a let or a const. I'm down. But I know this is a tricky subject in general. Like I said, this took me months and years to understand. And it is fun to get wrap your mind around it, but if you don't get it on the first try, don't feel bad at all. It definitely you just practice with it, and eventually this ugly thing rears its head. Is like, I can help with something that's really difficult, and it does. So that's what recursion is there for. Or that one day you actually need it. Any other questions about this?
You said you were gonna show us how to do this with the loops. Does it take a long time?
With the loops, which loop? Oh, I mean, so what I mean by loops, I mean that's what I was thinking. We can go over it real quick. Yeah, for sure. So we have our num array in here. It was originally 5, 10 to 42. So we come in here. Clearly the array is not empty, so it's not 0, so it won't return. We come down here. It just initializes that array, no biggie. Finds the minimum value. The minimum value is going to be 2. 2 is pushed into the sorting array. 2 is then removed. And we ask the function to run again. The function comes up here to 23. It's down to 3. It's not 0, though, so we're not going to return. We come down here, find minimum value of that array that is now 3. That has 3 things in it. The next lowest would be 5. We push 5 into there, so sorted array. So the sorted array in one instance is 2, and the sorted array in another instance is 5. So we have two kind of situations floating out there. So that's 5. We get rid of 5 on this one because we're splicing again, and we ask it to run again. Comes up here, it's not 0. We find the minimum value, which in this case is 10. So we have a 2 out there floating, a 5 out there floating, now a 10 out there floating. And finally, we come down here, we get rid of that 10. We ask it to run again. Comes up here and runs again. It's going to find the next one is 42. So pause here. We have a 2 floating out there. The next we had a 5 floating out there. Next we had a 10 floating out there. And next we had a 42 floating out there in that exact order. We come back up here and we remove it again, and we move that 42. It is now 0, so it returns an empty array. We're finally able to come down here and say, okay, add the sorted array, which at this instance is 42. Add that empty array to it. The array is still 42. It returns again. So after that, it returns the sorted array. So then we had 42. So then we come back up here, and it comes back into the instance where it's 10 in the sorted array. It's going to add the 42 to the 10 array. So it's going to become 10 and 42. So that's what happens here. We return the sorted array again. It exits this loop. This is now going to be 10 and 42. We add the 5 array to the array of 10 and 42.
And then 42.
Merge together. We have 5, 10, and 42. Now at this line, we return 5, 10, and 42. Now we're back to that first original instance. You're back within your own dream, not in a dream within a dream within a dream. You're back in your own dream. So we had the return sorted array of 5, 10, and 42. Sorted array in this instance was 2. So we have 2 over there, and we have 5, 10, and 42. They combine into 2, 5, 10, and 42. And then we return that sorted array finally back to the original caller, which down here is our console log. So our final result is the 2, 5, 10, and 42. So again, really do think about it as a dream within a dream. It's an exact copy of the situation, just with the variables a little different in that case. That's what the recursion really is. It's just taking a copy of that function, and those variables might be a little bit different, but it's doing the same exact task. So that's what recursion really is.
Thank you, Kat.
Yeah, absolutely. So that is it. That's it, I believe. Let's go and double check here on the studio. Yeah, we're down to 11.11.5. We're done here. So any final questions?
Just that one, not with this topic, but with the mapping, the array mapping. Like when we declare an array, the array name points to the container, right? And inside, the items can be changed. So when we say array.map and then pass a function, then the function would be pointing to the items in the array, not the container, right? Or I don't know, it's been bugging me.
So the item within the mapping is pointing to the stuff inside of the box, stuff inside of the container. So
The
each
function.
item, so the function is asking for that item. The
Okay.
function has a parameter of item. That
Okay.
item is each individual piece in the box.
Piece.
It's in the container.
Okay, thank you. I was confused about that a lot. Thank you so much.
Yeah, absolutely. No, it's all. This is all the fun stuff to wrap our heads around. All good. Yes, ask as many questions as you need. All right. If there
Thank
are
you,
no other
Kyle.
questions, everyone. Absolutely. Thanks for hanging on to the end there. Awesome, fun studio. Hope everyone enjoyed that one. But that is all we got tonight. So I'm going to stop the recording.